Hi there. For this video, we'll be having an introduction about the systems of linear equations. So in general, a system of linear equations or linear systems are sets of two or more linear equations that all have the same variables. For instance, if we have x plus y plus z equals 2 and 3x minus 2y minus z equals 0, and lastly 4x plus 3y plus z equals 3, then these three are a system of linear equations since all of these are degree 1, clearly. Degree 1 out here. And all of these equations have the same variables x, y, and z. So this is an example of a system of linear equation. For our discussion, we'll be focusing on linear systems in two variables. So that is, in general, we'll have a sub 1x plus b sub 1y equals c sub 1 and a sub 2x plus b sub 2y equals c sub 2. So this is our system of linear equation in two variables. So take note that in here, x and y are the variables. Let's write this one better. X and y are the variables, while a sub 1, b sub 1, c sub 1, and so are the a sub 2, b sub 2, and c sub 2 version. These are the constants. Also, take note here that the number of equations in a system is, in general, equal to the number of variables in those equations. So like in this one, since we have two variables present out here, we have x and y, then it follows that in the system, we should have 1, 2. We have two equations, two linear equations to be exact, in this system. So those are the things that you need to know in dealing with systems of linear equations. Also, take note that we focus our discussion only in two variables, since we have only discussed so far about the Cartesian or the 2D plane. Now, one of the main things that we do in systems of linear equations is finding its solution. So when we say solution of a linear system, we simply refer to the intersection of the given lines. So for example, show that the point 3, -1 is a solution to this given linear system. So how do we solve this one? What we do is we simply plug in this given point to each equation. We need to show that this point is valid for each equation. When we show that this is true, this means that these lines passes through 3, -1. So therefore, they intersect at that point, which makes this point a solution. So that is the idea that we'll be using. So first, let's plug in 3, -1 to this first equation out here. So we have here 3 plus -1, and that will give us 3 minus 1, which is 2. So 2 matches the 1 out here. Therefore, at this point, the first equation holds. For the second one, let's plug 3, -1. So we have here 3 minus -1, and this will give us 3 plus 1, which is 4. So it also matches the right side of the equation in this second equation. Therefore, we say that the equation also holds. Therefore, we can conclude that 3, 1 is a solution. So the two equations out here intersects at that point. And indeed, if we show its graph, we can clearly see that. So this blue line out here is the x plus y equals 2. And this orange one is the x minus y equals 4. Clearly at the point 3, -1, the two equation of lines intersect. So now that we know about this, there are actually 3 types of linear systems. This is based on the nature of its intersection. So we have the inconsistent, the consistent independent, and the consistent dependent linear system. So let's go over these one by one. So first, we'll have the inconsistent. So an inconsistent linear system occurs when the two lines are parallel, which we know to occur when given two lines, their slopes are equal with different y-intercept. With this type of system, we have no solutions, since if both lines are parallel, they can never intersect. So these are the things that you need to remember in the inconsistent type of linear system. Also, take note that this part out here is obtained from a discussion on parallel lines, so you may check that video out to learn more about that. So if we show its graph, it will look like this. So you can see we have two parallel, or rather a set of parallel lines out here, with the slope being the same, since these two are in their slope-intercept form with different y-intercept. So as you can see, these two lines can never intersect, therefore they can never have a solution. So that is the inconsistent linear system type. So now, let's move on to the next one, the consistent independent type. With this type of linear system, it occurs when we have intersecting lines. So this happens when given two lines, their slopes are not equal. So if their slopes are not equal, then they have different steepness or inclination, so there is a chance that they meet at some point. So in this type of linear system, we have one solution, their intersection point. So like in our example above, the point 3, -1 is the solution, since it is the intersection point of the two given lines. So indeed, if we show its graph, we can clearly see here, so this is two different lines with in their slope-intercept form, so we can clearly see that the slopes are not equal. So when the slopes are not equal, the two lines have one solution, since they intersect at one point here. So this is the consistent independent type of linear system. Lastly, we move on to the consistent dependent type, the last one. So this occurs when we have overlapping or coinciding lines. This happens when given two lines, they have the same slope and y-intercept. So all is same. So technically, they are the same line. When this is the case, we have infinitely many solutions in our system. So I don't have a graph out here since seeing the graph is not really that nice, since it would just look like we have one line since the two lines overlap. But the idea is that if we have a line out here, that's line 1, and the second line will be right in top of it. So it's just overlapping. That is why there are infinitely many solutions, since the two lines intersect at every possible point. So those are the three types of linear systems. I hope that you have taken notes on it, since now we'll be trying out some examples. So our goal here is to determine the type of linear system given a system of linear equations. So first, feel free to pause the video if you want to try this item on your own. In fact, you can do this in the rest of the items since we'll have 3 examples out here. So just feel free to pause it so that you can work on it by yourself first. Okay, so let's start. So in this one, we have y equals negative x plus 3 and y equals negative x minus 6. So observe that these two are already in their slope-intercept form. So it's easy to observe their slopes and their y-intercept. So first, observe that the slopes out here are equal, since the slopes are -1 for both. Moreover, we observe that the y-intercept is not equal. So when this is the case, what can we say about the two lines? We know that these two lines are parallel. Therefore, the system is inconsistent. Indeed, if we show its graph, we'll have two lines out here that are parallel to one another. And so when we have an inconsistent type, again, we'll have no solution since they can never intersect. Let's have this next one. So in here, our goal is to determine the type of linear system again. So we're given y equals 5x plus 1 and y equals negative 3x minus 5. Again, since these two lines are already in their slope-intercept form, we can easily inspect the slope and the y-intercept. So inspecting the slopes, clearly, we have different slopes out here, since 5 is not equal to negative 3. So the slope of the first line is not equal to the slope of the second one. So when that happens, we know that the two lines will intersect one another. And when we have an intersecting line, we know that the system is consistent independent. And indeed, if we show its graph, we can clearly see that these two lines intersect at one point or at some point out here. Since inconsistent independent, we have one solution. Let's have this last example. In here, observe that the first one is already in its slope-intercept form, but the next one isn't. So let's try to convert this second equation to its slope-intercept form so we can easily inspect the slopes and the y-intercept in this one. So in here, so let's write that one down. What we can do is we can divide 3 both sides. So this will give us y equals 1 over 3x minus 6 over 3 will give us 2. And what can you observe? These two equations are actually the same, since they have the same slopes and the same y-intercept. So therefore, if that is the case, we know that this linear system is consistent, dependent. And indeed, if we show its graph, again, it might not be evident, but these two lines are just overlapping one another. So in this type of linear system, again, we have infinitely many solutions, since these two lines intersect at every possible point. So those are the 3 types of linear systems. To end this, here's an exercise that you can work on. So basically, this is a table of the 3 types of linear system, and your goal is to supply the missing component out here. And after completing this, you can use this one as your reference when dealing with linear systems, more specifically their types, as this will be useful when we move on to solving linear systems. So that's it. I hope you enjoyed this one. Feel free to comment down below if you have any comments, suggestions, and recommendations for this video and this channel as a whole. So that's it, and that's all for this video.